Okay. Hello, folks. I am absolutely exhausted. Um, I went and got a haircut. I went for a little run. I got some food. Here's the plan. I'm gonna stream for an hour and a half, maybe 2 hours. I'm gonna take an hour or two off to relax a bit, and I'm on all day tomorrow. All I want to do right now is I want to get most of the LLM heavy crap out of the way if I can. Because I really, really want to get to the point where I'm just manually cleaning stuff up and like actually producing something that is made for humans and not for stupid LLMs. To do that, it's going to require wading through a bit more sewage, though. I think that let's fix here. This is what we're going to do. There. 3 tests need to be updated. The M speed one, the profile one. Actually only 2 tests. Yeah, the M speed one and the profile one. And then we got to port a bunch of files over. Realistically, all this requires me to do is make sure that this thing doesn't make a mess in the process. And I think the only other major things that are going to still need the LLM are we have a couple places where there are redundant versions of things because we don't know which one is going to be selected. So like stripping out all the redundant stuff once we make that decision. And then after that, hopefully the code will be nice and succinct enough that I can just start going through by hand and like removing all the crap. Hey, Pepe. I'm not saying I'm not going to use it at all, but I definitely don't want to use it anywhere near as much as I've been using it for this. This is awful. I don't think it slowed me down, man. I actually think that I did do stuff faster, but I fucking hate this work. It's awful. It's just a massive amount of stuff for Puffer 4 that, like, there's not really a way around it because of the way that Torch works. int 2 mil. It's way better, man. That's way better. Statically linked. Very nice. Oh, I see. That's fine, it can do that. Just decoding the nth name in. Nice. I want to see how much code we've ended up with. Process of doing this crap. Oh yeah, I wonder if we also have any word from Jonah on Discord. See. Let's see, Max. Oh, I do have a couple messages from him. Okay, let's see what we have here. Callbacks. Yeah, so we're definitely going to just end up merging the two tests, I'd say. Or fully separating, one or the other. Heh, weird. No big deal. Well, this is doing this. I shouldn't just be like lounging. Let me think about. Do we want 2 tests or 1 test? It's static linked now, right? So substantially easier than before. And we may as well just have 1 test, I'd think. If I can get it to compile reasonably fast, I'd say. Which I probably can. Yeah. Because it's static link torch, right? So that should then mean if we don't change torch, probably we can do faster without it. Should check that. That'd be nice. Learning rate. This is funny. There's something for cyclic learning rate. Cosine annealing. Yep, already done it for you. If you've thought of it and it's a good idea, it probably exists. lib static. Hey. Use torch. Probably we can clean this up a lot. I have very few brain cells remaining for the day. I think instead of trying to like think about how to clean this up, I think that'll be part of tomorrow. I think we just get all the other M's ported over. That's like fully automatic super brain dead. I just have to make sure it doesn't screw up. Let's fix this first. I mean, hey, what can I say? I've streamed 19 hours in the last 2 days. So with this stream, we'll make it 20 or 21 hours. Tomorrow I will be refreshed. Because instead, like, last night I just, like, went to sleep, woke up 7 hours later, and immediately started streaming. I'm gonna get a little bit better rest today. This also takes forever to compile. Not acceptable. Ohms go away. So it wasn't like a go away type of a problem. It's just the way that we're doing coup de graphs. It's very memory intensive, and it's not really a problem because of the way that most of our stuff is set up normally. Like, there's plenty of memory for this. But that architecture specifically was doing some crazy things. So it's fine for now. I added a kernel. We might have to do more later. There's technically a way around it, but like, to really fully fix that error, or to like fix that the way it should be fixed, we just have to delete torch. Like, torch is just bad. There's no way around it. Oh, that's Peru. Yeah. Yeah, it's kind of bad. Solving. So the only way to solve it is like you say, doing static everything. But you pretty much have to delete torch at that point because we're graphing stuff. So you have to pre-allocate all the activation buffers, but you actually have to pre-allocate different activation buffers for each graph, which is num buffers of them. So you really just have to get rid of torch pretty much. Like either that or you make a total disaster of the code. I spent a couple hours on it and there's just no clean way to do it without like replacing torch. I mean, if you want to come up with a nice way to do this in Puffer, such that we can essentially ship a Theseus torch and just like bind the very, very last bit of it to torch, that would be awesome. Let me clean this up a little bit and then I'll sort of start showing you some of the stuff we've been doing. We are at 12.5. I did manage to do one other cool optimization that got us a couple 100,000 SPS today. Take a look at this. I'm pretty proud of this. This is because this was just kind of clever. Where's the init? Is it mu1.h? Okay, yeah, look at this. When you make muon, we go through all of the weights, we go through all the parameters in your network, and we replace them with ones that have been allocated in contiguous memory. And this just works with any network as as an optimizer without having to do anything. And then boom, you get to vectorize the update. Isn't that cool? So I got to do one cool thing today. You can't vectorize the gradients. If you could vectorize the gradients, it would be even better. But just vectorizing the weights is already pretty cool. I can't let you have all of the fun, right? Yeah. Well, it's not your fault you don't understand the training loop. The code sucks because of all this torch crap. We went to static linking for the environments because I just didn't want to deal with like there was some slowdown in shared libraries and I just didn't want to deal with it and I thought like these shared libraries are a pain in the ass anyways. Let's just do everything static linked and we won't have to think about it. So I did that. I have to port the rest of the environment, but literally Claude can do that. It's trivial. It's just like update API. Okay, this runs. Parity with puffer 3. No changes to M's. But you rip out the entire network stack, don't you? To be fair, mirrors the LSTM 1-to-1. Well, then we'll definitely want your LSTM implementation if you have faster LSTM. You know, we can have that as a backend option. For eval, Well, the problem with LSTMs comes in training, right? Eval, it's fine. LSTM is a perfectly serviceable architecture for eval. There's huge delta between. I don't have formal education. So here's the thing with Sutton and Bardo. It's a bunch of like formal background. The stuff doesn't actually work. Here, look. For reference, I've never read this full book. I've read sections of it, and it like I wouldn't even say that reading sections of this were a major part of like my background. It's mostly from papers I've read. So okay, look, anything tabular, dated, like irrelevant. Okay, finite MDPs, there are no algorithms in here. There's just like a bunch of theory about policies and value functions. Dynamic programming, dated. Monte Carlo, this is search, irrelevant. TD, relevant stuff, but the actual algorithms introduced are like not actually usable. N-step bootstrapping, like these are sections. So bits of this are used in what I use, but that's about it. Planning and learning with tabular, irrelevant. Let's see. This is all irrelevant here. Yeah, this is all irrelevant here. On policy control and stuff, yeah, irrelevant. Like eligibility, so there's some stuff in here that's like used sometimes, but unless you're doing pure algorithm research, no. Okay, policy gradient, they stop before it becomes useful. So this is the basis of stuff, but like they don't actually get to the usable methods. This is just a weird section. And that's it. There's nothing else in here. So like, you know, you've read 400 pages, 500 pages, and by the end of this, you can't do RL. That's the problem. I mean, if you want like most of it, like just understanding PPO is the vast majority of what we have. So what we have is we have PPO, we have a slightly better advantage function, we have this like prioritized sampling thing on policy prioritized sampling that we came up with that's based on the Gigaflow paper. We have a better optimizer in Muon. And I believe we have one other small trick. But it's pretty close to PPO. Papers instead? Yeah, papers. If you want to actually do algorithm work and get deep into the algorithm side, there are sections of the Sutton and Bardo book that you should definitely read. But if you're trying to like learn stuff quickly to be able to actually make RL work on problems and then fill in knowledge as you go, like my article plus projects plus some papers, and then eventually come back to read some sections of formal, like Sutton and Bardo is good. And you don't just read random papers either. Read the ones I suggested, because most papers are just wrong. All right? Like most of the papers in the field are wrong. For instance, in exploration as a whole, there are 1.5 good papers in all of exploration. You're writing? Well, since you have the low level background, yes, that's exactly what you should do. I'm actually really hoping that we can even drop the prioritized sampling once we have state set based exploration, which is Puffer 5. Because the sampling that we do in training actually slows stuff down quite a bit. So exploration is this entire not well defined area of RL where it's like, RL doesn't explore well, we should do algorithms. But then they don't actually define the problem, and most of the papers in this are both wrong and misguided and not even solving a useful problem. Um, Plan for Puffer 5, the one actually good paper is Go Explore, which is a very, very stupid algorithm. Like, you can't use the algorithm directly, but I think the core idea is good if you are willing to build all your simulators with state set capabilities. What is this paper? Yeah, this one. I actually don't like the follow up to this one as much. It's a very, very simple paper. Like, you can't even use the core of it because this whole cell representation thing is completely intractable, right? Like, you can't solve that. But I don't think you need to. We have some ideas on what to do about this. Bayesian. I haven't useful for hyperparameter tuning, like Gaussian processes. It's nice for low dim optimization with like really sparse data. I don't know why you like look at this for general RL. It's really just for hyperparam tuning. But I mean, I'm also a Philistine who doesn't understand probability, so thing. This is not including correctly. Namespace PufferLib, right? For sampling? Sampling what? The only thing you sample are actions, right? Damage. Weird bounds. Training batch. Sampling training batches. Oh. Hmm. Eh. I think we just do multinomial over advantage right now, man. Uh, Danny, so we use Gaussian processes for hyperparameter tuning because it's like a low dimensional but very data constrained space, and everything else I've tried does not work anywhere near as well. The fact that this test is 2,000 lines is disgusting. It's longer, actually. Ooh, Tim, look at this. Tim's got Sokoban. Huh? Oh, launch function dated? I think launch function is dated. Yeah, launch function is dated. Compile's way too slow as well. Mm-hmm. computer vision. I only ever recommend that people who want to do a PhD do a PhD. I never try to convince somebody to do a PhD. Like, you do a PhD because you're damn sure you want to do a PhD, and that's it. Right? Okay, we get our profile back. Nice. That's important. This file is way too long, but I am out of brain for thinking about it today. Okay, this still runs. 12 mil plus. Include the breakout env, right? Okay, this runs. Let me just make sure it's actually compiling. It's compiling, good. This takes an env. I think this is just not getting used. Yeah, this is dated. Oh, well, this is actually already correct is the thing. it done here. Mm-hmm. It's fast, or is it? I like it that way, man. I hate that I have this stupid Claude window here. I'm thinking once I get this project into a better spot, because I have all this torch mess to clean up. It's gonna be way more human editable, and I think I'm just gonna ditch Claude for the most part. I might use it once in a while, but it's not gonna be here like is, no, half my screen what I'm typing in half the time. It just does so much stupid stuff. It's like I I cannot be bothered following just twisted crap all day for the sake of saving typing. If I could get like an extension that lives in my like in Vim where I can just like, type a comment at a specific spot, that might be nice. Integrates it inline. Yeah, but you don't need it to be it. I don't need an IDE in order to have a plugin. I used VS Code for like a year. I was very happy leaving it. I was like, oh wow, I actually kind of enjoy programming again. Yay. I got to the point where I had VS Code, like I just disabled all the visual stuff, so it was just like a one screen editor. And I was like, well, why the hell am I even doing this? Just use Vim. The only reason I was ever doing it was for the container plugin before I had Puffer set up to just like do the containers nicely for you. Yeah, at least you didn't grow up with like NetBeans or Eclipse, man. I you have my sympathies if you do Enterprise C++. plus plus. The fact that you see me writing any C++ plus plus here, this is not by choice. I would very much like to just be writing C. Mm-hmm. You know what? I think we'll just leave this. We'll leave it like this for now. We can always do it in passes, right? Be way easier. Gonna do a port script. Mm-hmm. Good. Mm-hmm. Yeah, now it'll just do it. It's nice. Yeah, this is super nice. Almost no changes required. Yep. Super easy porting. It's nice. Lots and lots and lots of stupid ports. Yeah, it should not mess any of these up. This is like complete unambiguous tensor template matching. Act type will just be double for everything, I'm sure. Yep, we ported this. Worked with Radford. I didn't work with him directly. I got to speak with him. I got to hear. I mean, I had lunch with him a couple of times with just like the main group. He was an awesome guy. Radford's great. Really, really great guy. I don't think anybody has like anything bad to say about Radford as a person. And I mean, he's a great scientist. He's not an engineer by any means. Great scientist, though. Um, yeah, I saw that briefly. It looks like he was advising a pretty basic project, maybe a student project. I don't know. I mean, it looked like a simple, well done idea, but I don't know if he said anything about it. He posted on X, really? Yeah, I hope he's doing okay. This is 2018. Oh, he didn't post. He just reposted it. Cool guy. Seeing the end of binding. Oops. No, it has it. Push BF16. Ooh. Ho ho. That's a nice present. I've been waiting for that. Oh, hey guys. Do you see? 5K. We'll wait to post until it's actually 5K because it's rounding up. 50 more star, guys. It's 50 more stars. Come on, feed the puffer a star, please. Just go do it. It's free. It helps my work. Exponentially puffing. I'm gonna have to do a merge for this, I'm pretty sure. Yeah, templating my nice standalones, but it's okay. You did float star advantage, okay. Let me get my current build stable, merge it, and then I'm gonna merge your PR. I wanted this so much, man. Yeah, this is gonna be good. It's gonna be a slightly awkward merge, I think. Tell me though, speed? Anything? I mean, it's not expected to do a ton on breakout. Like, it's for bigger networks. Though actually, hey, Jonah, one thing you can try real quick, bump the hidden size on breakout to like 512. And then try with BF16 versus with float 32. See if that makes a difference. 5 to 10%. But is it 5 to 10% on 128 size? Or like did you try on 512? See, if you up the hidden size to 512, so basically I'd expect BF16 to make a bigger difference the bigger the networks get. Which is super important because then it would mean that we're shipping at least one feature that improves big net speed a lot as well, right? Messaging on Discord, one moment. Testing both on 512 now. Cool. I think this should be reasonably good. This just needs a forward deck. Sure. Little shenanigans. Oh. That's bad. That's kind of fine though, that it just does that. So much crap. Ah, okay, so that was bad then. No, the binding gets compiled with it. That doesn't make sense. No. Bad. Yes. Yes, that is what we want. Not what we want. Maybe we have the structure wrong. Oh, we have results. How did contributing new M's help Puffer? Good question. Not a new question. So, nobody in the world can predict how useful a new env is going to be. Let me give you some examples. 2048. This ended up being a ludicrously useful research environment. All right, it ended up being very, very difficult and scaling well. Tetris, great medium complexity env that's really awesome to watch. Breakout turns out to be the simplest possible environment that's still a pretty good predictor of whether your thing is working and is going to work on other envs. Snake, very nice, simple, and fast multi-agent environment. Slime Volley, very good starting point for self-play research, right? Like, lots and lots of these envs end up being useful, which is why we port all of them. And we essentially track progress on all the different envs. And, the goal is that we're doing better on all the envs in Puffer 4 than we are in Puffer 3. Different envs expose different bottlenecks. It's essentially like you're writing a whole bunch of test cases, but instead of it being like a boring thing, you're actually writing a cool demo for our agents to solve. Plus, it's a great way to learn, and this is oftentimes how people learn and get involved in the algorithmic side and stuff if they're new to RL. Wait, at 512 hidden size, 3 mil SPS B16, 2 mil FP32. Ooh. Yeah, so run pod can be sketch. Okay. So I will test it, but if we get like 50% off of the bigger nets, you have done some awesome work for us. That's awesome. Let me unfuck our end findings, and then we will see if I can get your thing merged before I am falling asleep. Because this is now well over 20 hours streamed in the last 2 days. Like, good BF16 is so useful, man. You know why, right? Like, because this is going to give us something that when we scale our bigger networks, it would be kind of disappointing if we only get 20% perf or something, right? On our bigger networks because the overhead wasn't as big of a factor. Like, we'll still get some perf benefit on everything, but it would be kind of disappointing if I did all this work just for the smaller nets. But because we have the custom kernels where we actually keep the ops in FP32, we can actually control our numerical stability way more than we can with Torch and BF32, BF16. So like, I think this is just way better overall. I do hate the fact that it means that we'll have to keep the templating. Does everything support BF16 though? Like, I can't just keep the BF16 implementation, right? Because not everything. Meh, sketchy. I don't know. Templating is so annoying. We have like thousands of lines of binding code. Like only use BF. Yeah, I don't think we can do that. I think actually, the other thing I was trying to ask, oh, I assume the more complex would be the more useful. That is also true provided they're fast. You have to be quite a good dev to make a good complex M though. Um I hmm, interesting. Torch keeps D-type specific. Torch does it in a really gross way with a macro that gives you absolutely terrible compile messages when you do anything wrong though. I'm wondering if we can do the other thing I didn't know, right, is whether we could have CPU backend without having to duplicate all the code. I don't know about that as well. There's some stuff that we need to like just get set up correctly. But hey, we're getting all the perf in at least. Oh, hello there. It's nice. Like, how fast is Pong, I wonder? Doesn't learn. It's good. Well, we have all the bindings. Let's make a commit. doing this manually so I don't screw it up. Do it. Yes, that did it. Okay, so let's do this. Let's merge the PR. Let's merge the B float PR. I'm calling it a night. Where the heck is the? Oh, huh? Ooh, I know what happened. Yeah, I see what happened. There we go. See if this works. uh, Yo, this is my guy. Oh, it's definitely faster. 10% faster. What happens if we do, what if we do this? Isn't it great when we get new contributors that just like come up and rock shit? That's great. 2.4. Oh man, you cooked this, yeah. Holy shit. Alright. The 20-hour, 21-hour stream the last 2 days was worth it. This kicks ass. Near damn double speed up. Holy crap. So let's just put this into perspective, okay? So we got 4 mil SPS, right? Um, so if we were being fair in flops, it's quadratic. So 4 times 16 is 64. So that's like the equivalent of 64 mil FPS worth of flops for the smaller nets. uh, dude, you got this so damn good. Holy. Does this work? I'm getting a beer or whatever after this and calling it a night. Holy crap, guys. Oh. Really, my mouth 3 seg faulting? Can I try default? How am I supposed to test my ridiculous new thing? Ah, this is bad. I want to test Nerlin MMO3. That's not on you, I doubt it, because I tried it without the B float. This is probably on my port, dude. It's making the wrong number of M's. I can see it right here. You and Peru have just both mega kicked ass. Like, just, it's like, just show up and kick ass. Holy. That's awesome. Yeah, it doesn't have a shared init or anything. Calls a net. Not num agents. What has been accomplished this evening stream? Fixed a bunch of tests, got all the new static binds ported over, and Jonah just submitted us an absolute kick-ass B-Float 16 PR that has us to 13 million steps per second training. But the real kicker is for big nets, it makes big net training almost twice as fast. So not only is Puffer 4 now going to be faster for small nets, you're going to just get like a straight 2x on a lot of the bigger nets too. We just tested with 512. The benefit will be bigger for larger networks. But then again, all the other stuff in Puffer will be better for smaller networks. So you get faster, you get faster, you get faster, all y'all get faster. How would you define big versus small? So most of our optimizations, like in Puffer, most of the Puffer 4 optimizations are going to be for nets like below 2 mil params or whatever. This will let it scale, like this will be good for nets 1 mil params and up. So there will be overlap, roughly. I don't know. We just got the PR, so. No, not aim for. You don't have to aim for anything. That's the point, man. You don't have to aim for anything. Like, what happens is you sweep everything, and everything is faster. So now the optimum is going to be like, there's a ton of new configurations that will now be efficient. FC Relu. So I wouldn't get too nerd sniped by those, man, because so what that is, that's an experimental thing because that's an experimental thing that's for one environment because they have this weird pointwise encoder, and pointwise encoders just materialize a ton of memory. Also, that env isn't even stable yet, so we're not going to be able to fully test, like, architecturally whether that even works. So I wouldn't spend a ton of time on that yet. I have a quick question for you. Do you think that we can make CPU fallbacks for these kernels without making a mess of everything? Like, could we just copy the entire inner loop of the kernel into an inline function and then call it from CUDA or call it from C? Like, does that make sense or no? Because right now with Puffer 4, like, all our new stuff will just be, it, like, won't even work if you're not training on GPU, which is, I think, okay. Not great, but, like, okay. I mean, realistically, we have stuff fast enough now that, like, if we bothered putting a fallback in, people would probably be able to train at a mil SPS on CPU now. Why not just run the torch functions? Yeah, I think that that's the other option, right? Is we just say you just use the default torch. It's kind of dumb to care about perf, I suppose, on CPU. So if there's not an easy way to have it just be the same code for both, that's probably the play. Why not sweep in C? Isn't sweep just train in a loop? No, Jess. There's additional Gaussian process crap. Go look at the file, you'll see it. Ah, I see. Faster sweeps the better. 1 mil on CPU. Yeah, but I don't know how much of a pain it is. If it's gonna mess up the library, it's not worth doing. I'm only just getting into RL. The idea of hierarchical RL seems so intuitively. Okay, so you really should read my guide. There are a ton of topics in RL where if you just start reading papers, like everything is going to sound like it's really cool and works, and then nothing actually works in practice. Hierarchical RL is one of those. Exploration is another one of those. Um, a lot of the meta learning stuff is like that. So you got to be a little careful with that. So this is the thing that it takes a little bit more time to learn, not like engineering stuff, is the lit quality thing. Oh, that got farther. Logic for multi-agent is totally fucked up. This is why you don't let stupid language models fuck with your crucial code. I'm just gonna send this in a sec. Really? Well, that's super annoying, but it's late. I've been streaming, yep, plenty long. Let's at least commit this. We can still do breakout, right? I'm gonna have to start going through manually tomorrow. Yeah, it still works. 13 mil. 13 mil SPF. All right, folks. I'm getting myself a glass of wine. I'm taking a bit of time to chill. I'll be back first thing tomorrow morning. I'm streaming all day. And in the evening, I'm playing some games with a bunch of RL researcher friends. And we might decide to even stream it for the hell of it. So, all day back tomorrow. We're going to fix all the end bindings. We're going to try to get all the M's to be sane. We're going to try to get actually many different things training. And I'm going to try to avoid getting put into more rabbit holes. Jonah, you've kicked ass today. Peru, you've kicked ass today. Thank you all. If you want to help me out for absolutely free, while I'm busting my ass here on open source, Puffer, hungry, eat stars, feed Puffer star on GitHub. Free, click a button. When this number is officially 5K, we get to celebrate or something. I don't know. Other than that, Discord link if you want to get involved. Great place to learn. Follow on X